Hello my dear students, this video is for class 9 computer application subject. We are going to learn chapter number 3 values and data types. We human beings communicate among ourselves by means of a language. Similarly, Java is a computer language that is used to communicate with the computer. Every language is having some character sets. Similarly, Java is also having few character sets, and character sets in Java includes letters, digits, operators and delimiters. Character set of Java in detail. Letters. Character set in Java include all the letters from capital A to Z and small a to Z. Digit, all the digits from 0 to 9 and also the combination of digits. Operators, there are three different kinds of operators, that is arithmetical, logical and relational. Arithmetical operators are those operators which are used for arithmetical calculations like plus, minus, division, etc. Logical operators, they are used to compare various relational expressions, say and, or, not, etc. Relational operators are used to compare different values, say less than, equal to, greater than, etc. All these operators we will be learning in detail in the chapter. Lastly, delimiters or separators, comma, colon, question mark, bracket, these are all known as delimiters. Again, we are going to learn in detail about delimiters in the chapter. When a character is entered from the keyboard, a specific code is assigned by the system for its storage in the memory. Unicode is such a standard coding system created by Unicode Consortium, and that is used to encode a character in any computer language. Actually, it is a wide representation of characters in numeric form. It is a 16-bit code, and a code of each character is available under Unicode character set. I repeat again, it is a wide representation. It includes encoding for numerous characters available in the computer. ASCII code, or American Standard Code for Information Interchange, is an encoding system of decimal numbers represented in 7 binary bits. The range of code is not as large as compared to Unicode, as it is available only for a limited number of characters ranging from 0 to 127. As seen in the table below, ASCII characters and their ASCII codes, these are important topics which you have to learn. Especially these codes will be used while programming when it deals with character. So you have to remember these codes by heart for at least for 0 to 9, capital A to Z and small a to Z. Here you can see the difference between Unicode and ASCII code. Unicode, it is a generalized form of coding scheme for numerous characters of different scripts, whereas ASCII code is specific coding scheme used for only a limited number of characters. As we saw that it only supports a limited, that is from 0 to 127. Unicode represents higher range of code, whereas ASCII code represents limited range of codes. Escape sequence are some non-graphic characters which are used as commands to direct the cursor while printing. A escape sequence begins with a backslash followed by one or more characters, as you can see in this table, slash, that is backslash T. This means horizontal tab, that is, it allows the user to control the cursor's movement on the screen. It allows the user to customize the screen and to get a formatted output. Here is an example of escape sequence /n used for new line feed. By using this, the cursor skips the current line and moves to the next line on the screen for printing remaining part of the output. As you can see here, I have written system.out.println name Ayush, then \n, age 14 years, \n, and class 9. Now when you run the program and see the output, you can see that name, age and class all have come in different line. The reason here is that we are using \n, and here this means that you have to move, or the cursor, you are telling the cursor to move to the next line. One more example, that is of Backlash T. It is used to separate the values on the screen while printing by providing a gap of 8 spaces between them. It is also called tab spacing as it is similar to tab key on the keyboard. As we all know that by using tab key we can leave more amount of space as compared to the spacebar key. Similarly, if you are using /t in your output statement, it will give the same effect of tab. That is, look here, example, system.out.println, name Ayush, backlash T, age 14 years, backlash T, and look at the output. Name, age, and class all are printed in the same line by leaving space. That is, a space which is equal to 8 spaces. That is, which is equal to tab key. A token. A token is a fundamental unit of computer program. Like we say, a cell is a fundamental unit of any living organism. Similarly, a token is a fundamental unit of computer program. Every individual component of a programming statement is referred to be a token. For example, here we have a statement A is equal to B plus C multiplied by 5 and then a semicolon. Here A is an identifier, this is an assignment operator, B is an identifier, plus is again an operator, C is identifier, multiplication is again an operator, and 5 is a literal, and this is a punctuator. So from this we can understand that every statement in a programming language, it is basically divided into fundamental unit, and that unit is known as a token. All these are tokens, identifiers, assignments, operators, literal, punctuators, etc. Here we are going to learn about literals or constants. Literals are the quantities which remain fixed or the value which do not change throughout the execution of the program. They are known as literals or constants. I repeat, the values which remain fixed or which do not change throughout the program, they are known as literals or constants. Now there are 6 types of literals or constants, starting with integer literal. Numbers without decimal point are known as integer literals. Example, 14, minus 17, etc. Real literals, they represent the numbers with decimal point. Example, 0.009, 3.67, etc. Character literals are represents a single character enclosed within a single quotes. As you can see, single quotes and then A. So this is a character literal. String literals, it represents a group of characters enclosed within a pair of opening and closing double quotes. Example, computer. Many characters put into double quotes. You see character literal and string literals. What is the difference? Character literals, they are enclosed within single quotes, whereas string literals, they are enclosed within double quotes. Boolean literals, they represent only true or false, or Boolean literals either will carry true or will false. Lastly, null literal. It is used as a string terminator or to mark the end of the string. Our next token is identifiers or variables. A variable is a named memory location which contains a value. I repeat, a variable is a named memory location which contains a value. How to declare a variable? Int m. So when writing int m or float pqr, what we are doing is we are assigning a memory location for this variable m, which will carry a data type of integer. Now this value of variable can change depending upon the circumstances and problem. Look at the example here. Here it is written int m is equal to 5, and suppose say m is stored in a memory location like this. Okay, data value 5 is stored in location name m. Here, this is where it is stored. Now after execution, if there is a statement like this, say int m is equal to m into m. So that means what? After the execution, at the same place where 5 was stored, now it will be 5 into 5, 25 will be stored. That is, the value of the variable m changes in the memory after the execution. The location remains the same, but the value can change depending upon the circumstances or problems. There are few rules for naming a variable which are as follows. Number 1, a variable may have any number of characters. That is, a variable name can be with any number of characters. Number 2, it may contain alphabet, digits, dollar sign, and underscore. The underscore can be used in between the character to separate the words of a variable name. Suppose say I have a variable name like employee number. Employee and number can be separated by using an underscore. Lastly, the variable name should be meaningful, which easily depicts its purpose. For example, if we are doing addition of two numbers, say A and B, so it should be written sum is equal to A and B, so that we can understand easily by seeing sum that sum will carry the addition of two or more values. Our next token is assignments. Assigning means to store constants or a value in variable using a token equal to symbol. Equal is known as assignment operator. Now the syntax for assigning a value is data type, variable, and then the value. Meaning, first of all, when you declare a variable, say m, first of all you should say what is the data type or what value will be there in the variable m. When I say int m, this means m can store only an integer value. Similarly, when I say float n, that means n can store only a float value, that is a value with decimal point. So here are few examples how to store an integer value, a long value, a float value, double value, character, string, and boolean. Again, I will repeat character. It is a single character enclosed within a single quote. String, it is a group of character enclosed within double quotes. And boolean, it can have only two values, either true or false. Coming to a very important topic, initializing a variable. Initializing a variable. Why is it necessary to initialize a variable? When a variable is declared, it may contain a garbage value, that is any value, and that may create a problem during the execution of your program. Suppose, say example, I have a line like sum is equal to a plus b. Okay, when I say sum is equal to a plus b, before writing sum is equal to a plus b, we used to write sum is equal to 0. Now, why are we assigning 0 to the variable sum? The reason is if we don't assign a value, any garbage value or any value can come and sit in that variable sum, and ultimately what will happen, we may not get an appropriate result even if the logic is correct. So initializing a variable is necessary so that we don't get a wrong output because of garbage value. Now there are two different ways of initializing, that is static initialization and dynamic initialization. First type of initialization is static initialization. In this process, we have a direct assignment of a constant to a defined variable, or a variable is initialized at the time of its declaration only, that is before its actual use in the program. Like in the table you can see, as soon as we declare a variable, say int a, we are assigning a value 0 to a. Similarly, float f, we are assigning a value 0.0 to float f. Now from this table, you have to learn the static initialization or the default initialization of all the different data types. For integer, static initialization will be 0. For float and double, it will be 0.0. For character and string and boolean, we have different type of initialization. These initializations you have to learn because question can also be asked like what is the static or the default initialization for a character. Then the answer required is C is equal to in single quotes backslash U and 0000. So this table you have to learn by heart, the static initialization for different data types. Now, second type of initialization, that is dynamic initialization. Now, this type of initialization is done at runtime, or a value is assigned to a variable during the execution of program logic. A variable is assigned with the outcome of an arithmetical operation or logical function. For example, here we have declared three variables, say A, B, and C. Now C is equal to A plus B. So this variable C, it will get a value, or it is assigned with a value at the runtime, that is, during the execution of program logic, C will get its value. Similarly, P, K and F are three variables. Here we have written F is equal to P plus K. P and K, they are having static initialization because they are already given a value. But F will receive a value only during the execution of program logic. So dynamic initialization, it happens, or the initialization of a variable takes place during the execution of a program logic. And the variable is assigned usually with an outcome of any arithmetical operation or logical function. Next type of token is punctuators. Now they are the punctuation signs used as special characters in Java. Punctuators are the punctuation signs used as special characters in Java. We are going to discuss three kinds of punctuators here. Number one, question mark. Question mark is used in a ternary operator. Now what is a ternary operator? It is an operator using three operands. In detail, we are going to learn ternary operator in the next chapter. Right now, I am telling you that ternary operator is an operator which deals with three variables or operands. Dot operator, it is used to represent the scope of a function, that is, a function belonging to an object or a class. Like when I write system.out.println, here dot, it represents the scope of a function. Next, semicolon. It is used as a statement terminator, or it indicates the end of a statement. For example, every statement in Java ends with a semicolon. Here you can see every statement in Java ends with a semicolon. Next token are separators. Now separators are the special characters in Java used to separate the variables or the characters. I repeat, separators are the special characters in Java used to separate the variables or the characters. Here we are going to discuss about four different kinds of separators. Number one, comma. It is used to separate multiple variables. For example, here I have written int a comma b comma c. So while declaring three variables to separate them, I have used comma. Next, brackets. It is used to enclose any arithmetical or relational expression. If we want to put any arithmetical expression separately, we can use a bracket. Curly bracket, it is used to enclose a group of statements. You are writing a group of statements by using curly brackets. And lastly, square bracket, they are used while making an array. I repeat, square bracket, they are used to enclose subscript or cell numbers of an array. Now, what is an array? That you are going to learn in the other chapter in detail. Next tokens are operators and keywords. Operators are the symbols or tokens that perform arithmetical or logical operations. Arithmetical operators, plus, minus, multiplication, division, normal operators which are used in arithmetical calculations. Logical operators, and, or, and not. These are used, logical operators are used to compare two or more relational expressions. Lastly, relational operators, they are less than, equal to, greater than, double, equal to, etc. Relational operators are used to compare two different values, or they are used to compare many values. Next, keywords. Keywords are the reserved words which are preserved by the system and carry special meaning for the system compiler. Keywords are special words which are having special meaning, so we cannot use them when and where we wish. They are special words and they have to be used at a particular place only. Example, class, public, throws, for, void, etc. These are the words, they are keywords and they cannot be used when and where we wish. Data types in Java. We have already seen few data types in Java like integer, float, etc. But why data types are required in Java? The answer is the compiler must know the type of data we are likely to supply for storage to ensure optimum utilization of memory space. In short, we can say that while declaring a variable, if a data type is specified, the storage for that particular data type can be easily done by the computer. I repeat, why we are using data types in Java? To ensure optimum utilization of memory space. Now, data types are basically of two types, primitive and non-primitive. Primitive can again be classified into numeric and non-numeric. In numeric, we have integer and float, whereas in non-numeric, we have character and boolean. And non-primitive data type include various other types like class, array, interface, object, string, etc. In detail, we are going to learn about both primitive and non-primitive data types. Coming to the first kind of data type, that is primitive type. The data type which are independent of any other type are known as primitive or basic data types. I can also say that primitive data types are those data types which were already there in Java when it was made. These data types are independent. They can stay alone or stand alone. They are independent of any other data type. The basic primitive data types are int, byte, float, double, etc. Now, they are also known as predefined or built-in data type because the system developers of Java has defined them. I repeat, they are also known as predefined. Why? Or built-in. Why? Because these are already there, or system developers of Java have defined them when Java was created. And in this chapter, we are going to learn in detail about three primitive data types, that is integer, float, and characters. Integer type. This type includes a positive or negative number without a decimal point. Integer type, they include a positive or negative number without a decimal point. Now, integers are also of four types, or integer type includes four different types, that is byte, short, int, and long. Byte, it is used for bitwise operation. Short, it is used for a small range of integers. Int, it is used for integers which are more than short integers. And long, it is used for large integers. Now, very important, the table which is given here, it shows the bit size both in bits and byte for different data types of integer itself. By looking into the table, you can understand that byte is the smallest, whereas long is the largest. Integer type is having four different types, and in that byte being the smallest with bit size of 8 bits and long being the largest with bit size of 64 bits. Again, in this particular table, you have to learn the bit size of different data type because such kind of questions is asked, like what is the bit size or byte size for int data type, or what is the bit size or byte size for short data type. So all the students are requested to learn this table, especially the bit size in both bits and bytes for different data types. Floating type data type can have or store a fractional number. Floating type or float data type are used to store a fractional number, that is a number with a decimal point. Now it is of two types, float and double. Float represents a fractional number with a small range, whereas double represents a fractional number with a wide range. Now look at the table given. From the table itself, you can understand that float, that is a small range of decimal value, it is of size 32 bits, whereas double, it is of 64 bits. So automatically you can understand from the table that double is bigger than float. So if you are having a bigger decimal number, say 12.126938.7, then it is a big wider range and double can be used instead of float. Again, you have to remember the bit size for both float and double. Next type is characters. Java considers a single character and a set of characters differently. A character is always enclosed within a single quote, as you can see in the example. Char p is equal to m. Now, char can store only a single character and that too within a double quote, a single quote, whereas a string is always enclosed within double quotes. As you can see, string p is equal to, in double quotes, computer application with BlueJ. We have already seen the difference between a character and a string, and here again it is considered that a character, it includes a single character, whereas string, it can include a group of character. Now again, bit size for both character and string, is important. You have to learn. Char bit size is 16 bits or 2 bytes, whereas string it is more than 16 bits. Why it is written more than 16 bits? Because string can be long. It can have any number of characters. It depends upon us how many characters we are giving, and so the string bit size cannot be fixed. It will depend on what we are giving the value for the string. Type conversion. Example of a mixed expression is given here. X is equal to C plus I plus F divided by D. Here C is char, F is float, D is double, and I is integer. Now in such a mixed expression, the result which is obtained in the variable X, it has to be in one form of its data type. I repeat, in such an expression where there are different kinds of data type, the result can be obtained in any one form of its data type. For that, we have to convert the various data type into a single type, and such conversion is termed as type conversion. I repeat, it is needed to convert the various data types into a single data type when we are having a mixed expression, and such expressions conversion is termed as type conversion. Type conversion is basically of two types: implicit type conversion and explicit type conversion. Implicit type conversion or coercion. In this type of conversion, the data type of the result automatically gets converted into the highermost type available in the expression without any intervention of the user. In such kind of conversion, what happens when you are having different type of data types? Depending on which is the highermost type, the expression will have the data type of the highermost type. Now, how do we know which is highermost and which is the lowermost? Now, here in this diagram, I have given a hierarchy of a data types. Now, in this hierarchy, the arrow moves from byte to double. Here, byte is the shortest or smallest one, whereas double is the biggest data type. Now, an example here is given: C is equal to A plus B. A is of integer data type and B is of long data type. Now, from this hierarchy, it is clear that long is higher than integer. Okay, so the data type of the variable C will be automatically taken as long. Again, I am repeating, look at the example given. C is equal to A plus B. Here A is of integer data type and B is of long data type. Now from the hierarchy given, it is clear that long is bigger than int, or long is having higher value as compared to int. So the data type of the variable C will automatically be long. Here, without any intervention of the user, Java by itself converts the data type into the or takes the data type of the highermost type, and such type of conversion is known as implicit type conversion or coercion. Here one more example is given. D is equal to C plus I plus F divided by D. All C, I, F and D are having different data types, and ultimately you can see that the final result of the variable D will be double. D will have a double data type. Reason why? Because char, int, float and double. Out of all this, according to the hierarchy, double is the highermost type. So after the calculation, the data type of variable D will be double. Now here one example is given. Array is equal to half or 1 by 2 A plus B into H. In this above example, division 1 divided by 2 will be taken as 0 and not 0.5, and so the answer will always be 0. When I say 1 divided by 2, both 1 and 2 is of integer type, and so in the answer only 0 will be taken. 0.5, half means 0.5. But when we are writing 1 divided by 2, automatically Java will take only 0 as the answer. So even if you write the logic correctly, the answer will always be 0, because multiplying any value with 0 will always result in 0. To solve this above problem, we have to write any division by adding 0.0. For example, here I have written area is equal to 1.0 divided by 2.0. Now both 1.0 and 2.0 is of float type. So in the calculation, instead of 0, it will be taken as 0.5. So 0.5 multiplied by a plus b multiplied by h, you will get the correct answer. So whenever you are writing division of any number, take care that you write them in float instead of integer. Second type of conversion is explicit type conversion or typecasting. In this type of conversion, the data type of the result will be depending upon the user's choice, or user demands the system to get the result in the desired data type. Look at the example given. Int a comma b, x is equal to a plus b. Now since a and b is an integer, addition of a and b should also be an integer. But before a plus b, I have written float in bracket. This means what? I am telling the system that although my a and b is integer, their addition result should be given in float data type. So in the above example, the outcome has to be int implicitly. But since I have written float in front of a plus b, our data type of x will be float. X is equal to a plus b. Since I have written float before a plus b, the data type of x will be float. All the topics of chapter number 3 we have already seen. Watch the video again and again and try to write the answers of the following questions. All the questions given here have been discussed in the video. In case of any doubt, watch the video again and start writing the assignment in copy. Given questions are also supposed to be written in the copy, but I will explain you what this is. Question number 1 is name the following. These are the name of the data types. Question is given, you have to identify the data type and write them. Question number 2, predict the data type of output of the following. 3 lines of code is given. R is equal to P plus Q is written. You have to write what will be the data type of this variable R. Similarly, P is equal to this whole expression is written. You have to write what will be the data type of P. What will be the data type of the output. Question number 3 is what are the resultant data type of following implicit conversion. Now this is implicit conversion, that is the conversion which is done or by the system. User is not giving its command, the system itself do the conversion. Now this conversion will take place according to the hierarchy, or it will take place according to the highermost data type. First one I will tell you, for example, I plus C divided by D. Now I is of int type, C is of char type, and B is of byte type. Now out of this 4, byte, char and int, the highermost is int. If you remember the hierarchy of the data types, the highermost is int. So the resultant data type by implicit conversion of question A will be int. Same method you have to apply for question B, C and D and write down the resultant data type of the following implicit conversion. With this, we end the video of chapter number 3. Everyone has to do the assignment in copy all the questions. Thank you and have a nice day.